Okay, so let's take a look at problems number 4 and 5. Again, you are going to be starting off with 81 grams of aluminum. Okay, and we're going to want to do the ladder. So we're going to go ahead and do our ladder. And we want to end up with atoms of aluminum. Okay, now we don't want grams, so we're going to automatically put grams of aluminum down below. We know that grams of aluminum equals 1 mole of aluminum. We don't want moles because we want atoms, so we're going to put mole of aluminum here, and we know that a mole of aluminum equals atoms of aluminum. Okay, now remember the word, and I'm just going to write it here, atoms, particles, molecules, they're all the exact same, just slightly different unit, but we can use these interchangeably, okay, depending on the thing that we're using. Okay, we got to look in our periodic table. If we look at our periodic table, aluminum is 27 grams. We know that our moles, the number of atoms that equals 1 mole, 6.02 times 10 to the 23rd. So Avogadro's number. All right. So our grams is going to cancel out. So grams cancels out grams. Moles cancels out moles. So now we're left with atoms. And we've got atoms here. It's exactly what we want. Let's simplify. Let's bring those numbers down. All right. So we have 81 times 6.02 times, and I'm going to put 10 to the 23rd. We'll just do it that way. Okay, all divided by 27. Now, we can simplify. 27 goes into 81. If you crunch that into your calculator, 27 will go into 81. So that's going to be a 1. This will go in 3 times. So now this makes it easy. 3 times 6 is 18 times 10 to the 23rd. However, this is not in scientific notation yet. Remember, right now we're at 18. That means the decimal's there. So we got to change this. We got to move that decimal over. By moving that decimal over, we have 1.8 times 10. Because we moved it forward, this now becomes 24. All right, 24 atoms of aluminum. All right, and that's how we finish this first problem. Just like that. Okay. All right. Very good. Let's move on to number 5. Okay. Number 5 is going to be very, very similar. We are going to start off with, this time, 34 grams. And this time you have a compound, NH3. We want to know the volume. So over here, our volume is going to be in liters, NH3. We don't want grams, so we're going to put grams, NH3. We know that grams is equal to a mole, NH3. We don't want moles, we want liters, so mole's going to come down again. And this will now be liters, NH3. Notice I am putting a gap here between our liters and our molecule. And the reason for that is because we want to make sure this L is a unit and not part of the molecule. So if you put it too close, it starts to look like it's part of a molecule, even though L is not a atomic symbol. Okay, it is a symbol for unit though of measurement. All right. Okay, let's plug our numbers in. So we already know liters is going to be 22.4 liters for 1 mole. That's a 1. We know that 1 mole here is going to equal to the grams mass. We need to look at our periodic table. Now, if we look at hydrogen, hydrogen has a mass of 1. 1 times 3 is 3, plus nitrogen. Nitrogen has a mass of 14 if we look on our periodic table. So 14 plus 3 is 17. So there's our mass for NH3. Okay, so grams cancels out, mole cancels out, mole cancels out. And now all we're left with is our liters, and that's what we want. So let's go ahead and simplify. Let's bring those numbers down. So we've got 34 going across the top times 22.4, all divided by 17. Now, 17 will go into 34. We got a 1 there. 17 goes into this twice. So this makes it a really easy problem. 2 times 22.4 is 44.8 liters NH3. And again, that is how we are doing stoichiometry.